All right, so we've covered what happens when the vertex is on the circle. We've covered what happens when the vertex is inside the circle. Now let's cover what happens when the vertex is outside the circle. Okay, so in, on, and out. And of course we have the central one too, don't forget, but that one's sort of the gimme one. So what I'm talking about here is you've got your circle and you're literally talking about where the vertex is outside the circle. Okay, so let's look at this angle here. Let's call that angle, let's just call that one, actually let's leave that name for a second because I'm thinking ahead. I want to show you why it works first, and if I change the name it might make it easier. So this is the angle I'm looking at. So hopefully you're realizing at least that it's got something to do with the arcs, right? We know something's going on with these arcs. We just got to figure out exactly what. So I'm going to call this arc X. I'm going to explain why. Actually, I'll you know what, this one I'll leave for a big reveal. So I'll show you why it works, and I'll show you how the formula came about, and then we'll actually do one. So here's X. Let's call this one Y. Okay, so that's the arc. And if this is X here, and this is Y, I want to draw in a triangle like I did before. I'm going to draw in this one here. Let's see if I can get this one to line up better. There we go. Okay, so watch this. If this is X, this angle right here should be half X, just like before. That's an inscribed angle. The vertex is on the circle itself, so it's half of its arc. Same logic for this angle here. If this is Y, this is 1/2 Y, right? This is the vertex on the circle. This is the arc that it's hitting, just like before. And I'm going to use the same exterior angle trick I used before. Focus your eyes on this angle with this triangle. This angle is going to have to equal this plus this. But you're like, Mr. Miller, what about this? That's the arc, so I don't want that. I'm talking about this. Let's call this angle 1. So then the exterior angle equals the sum of the interior angle plus the other interior angle that it's not next to. Okay, so look at that again. So this is the exterior angle. This is the interior angles. These are the interior angles that it's not next to. This angle here is actually the one that it's next to, but that's not even the arc. I don't even want that angle. And I want to figure out what angle 1 is. So the measure of angle 1, if I subtract half y from both sides, I get 1/2 x minus 1/2 y, which if I write it another way, is 1/2 x minus y. So what does that mean? That means that if in the circle the angle was half the sum of the two arcs, then outside the angle is half the difference of the two arcs. See, look, the arc is x and the arc is y. If I subtract x minus y and take half, I get my not my exterior angle, my angle that's outside. So this is what you end up with. Now, I don't need you to recreate this, by the way. I'm just showing you why it works. This is what you need to be able to do, but I wanted to show you where it came from. It really just comes from basic inscribed angles, which we've already done, and then an old rule, you know, the old theorem with the exterior angle. Okay, so half the difference. So on was half, in was half the sum, and out was half the difference. What would that look like in an actual problem? Oh, I'm glad you asked. So let's say you've got a situation that looks like this. You've got this, got one of these deals. They're telling you this is the angle you're looking for, and they're giving you this is, say, 60 degrees, and this is, say, 120 degrees. Actually, let's make it 130 degrees. I'm just making up numbers. This angle is outside. Well, according to my rule, outside the circle is half the difference of the two arcs. Which arcs am I talking about? Well, of course, it's these two, because those are the two that the angle hits. This angle cuts through the circle right where those two arcs are. And that's how you figure that out. That's how you know which arcs to use. What is the actual, what is the angle actually hitting? So that means the measure of angle x here, the x value is going to be 1/2 the difference of the two arcs that it hits. By the way, you always do the bigger one minus the smaller one. You're not going to get a negative angle, so you wouldn't want to switch those. And that would be 1/2 times 70, which is 35. And we just figured out x is 35. Bada bing, bada bang. That's it. So you've got 3 scenarios you really need to be able to do. Okay? You've got the vertex. Let's see if I can find it real quick. Vertex on the circle. There it is. You've got the vertex on the circle, which was exactly half the arc. You've got the vertex in the circle, which was half the sum, and now you've got the vertex outside the circle, which is half the difference. So there's 3 things to remember, and hopefully that'll get you going with the next section. Okay, as always, if you need any help, just let us know, and we'll talk to you later.